All right, let's discuss the discriminant for a quadratic equation. Now, here's the quadratic formula. All right, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is an equation that we can use, the quadratic formula, to solve a quadratic equation. Remember, a quadratic equation looks like this: ax squared plus bx plus c. This is the general or standard form of a quadratic equation, and this is where the a, b, and c come from in the quadratic formula. Alright, so the quadratic formula has the square root in it, and the square root, what is underneath the square root, is called the discriminant. So the discriminant is then b squared minus 4ac. Alright, that's the discriminant. Now, when you graph a quadratic, it looks like a parabola. We call the graph a parabola. Here's an example of a graph of a parabola. It might do like that, okay? Or it might do like this. Let's draw one that's upside down, okay? So this is a parabola, this is a parabola. It crosses, these two cross the x-intercept, axis in two different places. So they each have two different x-intercepts. Here's a graph of a parabola that only touches the graph in one spot, okay? So it doesn't cross the x-axis, but it does intersect the x-axis, so there is an x-intercept here. And then sometimes you can have a parabola that's up in the air, like maybe that or maybe this, okay? Well, each one of these has a different type of discriminant. Now, actually, there's not much difference between these two, but we are going to distinguish between two different types of real solutions here. So, for this graph, let's say that our discriminant is E, and I'm just going to abbreviate. Our discriminant is 30. Well, if 30 is my discriminant, if 30 is my b squared minus 4ac, when I look at the quadratic formula, 30 would be underneath the square root sign. We cannot take the square root of 30. The square root of 30 is an irrational number. Therefore, if I have a square root that is irrational, I can't take the square root of it, then I have two real irrational solutions. All right, so solutions to a quadratic equation, you see, are these x-intercepts. That's what solutions are. They're these x-intercepts. So solutions are x-intercepts. Now we also, remember, to get an x-intercept, you let y be 0. So we also call these zeros because we have let y be 0 to solve our equation and to get these numbers. And another name for these is roots. Now, roots can encompass even those that don't cross the x-axis. So over here, we have two real irrational solutions, two irrational x-intercepts. But what if my discriminant is 36? Well, 36 is a perfect square. So I can take the square root of 36, so the square root sign is going to go away. Well, when the square root sign goes away, then I end up with two real rational answers. So my solutions are two real numbers, again, just like these are two real numbers, but they're rational numbers instead of irrational. Now, you know, these x-intercepts could really be anywhere here and be rational or irrational. But the main thing here is that if your discriminant is a perfect square, you have rational answers. If it's not a perfect square, you have irrational answers. All right, well, for this one, this is actually what perfect square trinomials look like. Because a perfect square trinomial has two identical factors if you factor it, and so you get the same answer twice. We say we have one repeated solution. Well, then where does this come from? let's suppose that my discriminant is equal to 0. If my discriminant is equal to 0, I don't even have a square root. My only answer is x equals negative b over 2a. I have one answer. One answer, but it's one real answer. It's real, it's rational, and it's a repeated answer. So these parabolas, these quadratics, have a discriminant that is 0. All right, well, what else could my discriminant be? Well, my discriminant could be a negative number. Let's say negative 14. If my discriminant is a negative number, then what is under the root sign is a negative number. And of course, when we take the square root of a negative number, we get an imaginary number. And so here, you get an imaginary number. Well, there's no such thing as imaginary numbers on a real number line. So that's why our parabolas don't cross the x-axis, because these are only real numbers on a real number line. So here, if your discriminant is negative, you see that you have two imaginary solutions. So this is how the discriminant, just the discriminant, tells you a lot about the graph of your parabola.